So this is the 2014 Junior Cert Higher Level Paper 2, and we're looking at question number 2. The box for an individual mobile phone is 13 centimeters long, 8 centimeters wide, and 6 centimeters high, as shown. Part 1 says find the volume of an individual mobile phone box. Okay, well, the volume of a cuboid is length times width times height. So in our case, that's going to be 13 times 8 times 6, and that's equal to 624 centimeters cubed is the units because it's volume. These individual mobile phone boxes will be shipped in a large rectangular box. Below are diagrams of the nets of two large boxes that could be used, box A and box B. Here's box A and box B. And part 2 says show that box A and box B have the same volume. Okay, so you're given the 3 dimensions of the cuboid of the box here, the cuboidal box. So you're given the length, width and height. So the volume again will be length by width by height. And we'll be using that formula for both boxes. And we should get the same volume. So let's see, we've got 32 times 30 times 78. And that gives us a total of 74,880. Again, that's centimeters cubed. For box B, we're going to do 48 times 40 times 39, and that gives us, do this on the calculator, the same volume, 74,880 centimeters cubed. So there we've shown that both boxes have the same volume. Part 3 says what is the largest number of individual mobile phone boxes that will fit in each large box. Okay, so if we're looking at box A, well, if we look at box A, remembering that the mobile phone boxes are 13, 8 and 6, so if we want to know, do 13, 8 and 6, that's the length, width and height. Will they divide into these numbers here evenly so that this cardboard box can be full to the very top of the smaller mobile phone boxes? So we can see here that 32 is divisible by 8, 30 is divisible by 6, and we can check then, is 78 divisible by 13? So for box A we can say 32 divided by 8 gives 4. We've got 30 divided by 6 is 5, and 78 divided by 13 gives us 6 on the calculator. So box A can be filled to the top, filled completely. So let's see with box B what the situation there is. So box B, we've got 40, 48 and 39. So again, we can see that 40 can be divided by 8, 48 divided by 6, and 39 can be divided by 13. So there we go. We've got 48 divided by 6 gives 8. 40 divided by 8 gives 5, and 39 divided by 13 gives 3. So the largest number, that means box A and box B can be filled to the very top. Now they're both the same volume, so to find the number of individual mobile phone boxes, we're just going to multiply these 3 numbers together, or indeed these 3, because both boxes are filled to the top. So we'll see there 4 by 5 by 6, that gives us 120, and 8 by 5 by 3 should give the same if they're the same volume and they both fill to the top, and that gives 120 as well. So the answer is confirmed there as 120 individual boxes. Okay, part 4 says find the surface area of each large box. Okay, the surface area. So for box A, the surface area will be, you've got for this one here, the sides will be 32 by 30. This one here will be the same. This one here will be 78 by 30, as will this one here. This middle one here will be 32 by 78, and this one here will be the same, 32 by 78. This is for each side of the box. So we've got 2 of each really. We've 2 of the 32 by 30s. Show this by highlighter just so it's clear. So we've 2 sides, then we've got the bottom and the top are the same, and then we've got the front and the back also the same. So 2 of each of those. So when we're working at the surface area, it's going to be 2 times the 32 by 30 plus the 32 by 78 plus the 30 by 78. So each of those sides twice, and that gives us on our calculator a value of 11,592, and that's surface area, so that's going to be centimeters squared. Okay, so box B, again the surface area is the area of all the faces added together. So we can see here this one's going to be 40 by 39. This one down here is the other match for that, 40 by 39. Then we've got this one here, which will be 40 by 48, length by width. This one over here will be the same. And then finally we've got this one here, which will be 48 by 39. Similarly here, 48 by 39. So again, to use the highlighter, we've got the 2 sides here and here. We've got the bottom and the top, which are here and here when you fold it up, and the front and the back here and here. So the surface area then will be twice 48 by 40 plus 48 by 39 plus 40 by 39. So there each of the sides doubled, and that gives us a surface area of 10,704, and again that's in centimeters squared. Okay, part 5 then says the large boxes are made from cardboard. The cardboard costs €0.67 per meter squared. The cardboard just covers the net of a box. Find the cost of the box that uses the least amount of cardboard. Okay, so the least amount of cardboard, that would be the least surface area, which in our case is box B. So box B was 10,704. So box B, 10,704 centimeters squared. That's the surface area. So we have to find the cost of the box. So the box is 67 cent per meter squared. So the first thing we have to do is convert, because this is centimeter squared, we need to convert this to meter squared. Now you have to be careful with this conversion, because if you think about what's 1 centimeter, well, 1 centimeter in meters is 0.01 a meter divided by 100. Now, if we square 1 centimeter, we get 1 centimeter squared. So if we're squaring 0.01, we get 0.0001. So 1 centimeter squared is actually equal to 0.0001 meters squared. So that's our conversion there. To go from centimeter squared to meter squared, to make that conversion, what do we do to the number 1 to get to this 0.0001? Well, you divide it. To do that, you're multiplying by this, basically. You're multiplying by 0.0001. That's the conversion. So what we need to do then is we need to multiply 10704 by that, by our conversion. And when we do that, we get 1.0704. That's meters squared. So it's just over a meter squared of cardboard that we're using, and it's 67 cents per meter squared. So to find the cost now, we're going to multiply that by the cost per meter squared. So when we do this in our calculator, we get 0.717168. Now, this is money. It's asking for the cost. So if this is money, we're going to round this. This is in euro, because it's euro per meter squared. So we're going to round this then to the nearest cent. So we look at the third digit after the decimal. Does this 7 affect the one in front? The answer is yes. It knocks it up. So the answer then is 72 cent. So in euros, the answer is 0 euros and 72 cent. That's to the nearest cent. Okay, and finally, an average of 140 boxes is produced each month. Find the saving per annum, that means per year, if you choose to make the box that uses the least amount of cardboard. Okay, so find the saving per annum if 140 boxes are produced each month. Okay, so let's look at we've done the cost of box B for 1 box. So let's look at the cost of box A for so box A, remember box A was 11592 was the surface area. So what we're going to do then is multiply the 11592, multiply that by 0.001 for the conversion to meter squared. So that gives us sorry, there's an extra 0 there. That gives us 1.1592 meters squared. But then we're going to multiply that by the 67 cent. And that gives us 0.776664. And again, we're going to round this to the nearest cent, which would be, look at the third digit, does that 6 affect the 7 in front? Yes, it does. So that would be 0.78 euro. €0, 78 cent, basically, to the nearest cent. Okay, so then they want to know what would the saving per year be if you're doing 140 boxes a month. Well, the saving per box will be 78 cent as opposed to 72 cent. So the saving is 0.78 minus 0.72, which is equal to 0.06. That's the saving. And then that saving times 140 boxes, and then there's 12 months in a year. Because we're looking per annum, we're going to also times that by 12. So that gives us a saving then of, in euro, 100.8. So because that's money, it's 100.80. So €100.80 of a saving per annum. So that's the end of part 6 and the end of question 2.